Welcome to qnawire.
So we're going to Gauss's law, part A, and then take the spherical Gaussian surface because of the spherical symmetry of the charge distribution. So we can then say that for part A, rho in terms of the radius would be equal to alpha over r. We're going to say that the change in volume is going to be equal to 4 pi r squared times dr, and that the charge is going to be equaling the integral from a to r of rho of r prime dv. And so for a Gaussian sphere of radius r, we can say that the charge enclosed would be equaling the integral from a to r of rho of r prime times dv. This is essentially equaling 4 pi alpha times the integral of a to r of r prime dr prime. And so this is equaling 4 pi alpha multiplied by 1 over 2 times r squared minus a squared. And Gaussian's law says that the electric field times 4 pi r squared, which would be the essentially the electric flux, my apologies. This is equaling 2 pi alpha times r squared minus a squared divided by epsilon naught, the permittivity in a vacuum. And so the electric field for part A is giving us alpha over 2 epsilon naught multiplied by 1 minus a squared divided by r squared. This would be our answer for part A. Now for part B, here we're going to, the field is the vector sum of the field due to the charge, due to, not the charge enclosed, but q, lowercase q, the point charge, and the field due to the sphere. So we can say that the electric field of the point charge, E sub q, is equaling q over 4 pi epsilon naught r squared. And so the total electric field would be equaling alpha over 2 epsilon naught minus alpha over 2 epsilon naught times a squared over r squared, and then plus the electric field of the point charge, q over 4 pi epsilon naught r squared. And so for the total electric field to be constant, we have that negative alpha times a squared divided by 2 epsilon naught plus q over 4 pi epsilon naught. This must equal 0. And so the point charge q is equaling 2 pi times alpha a squared. And the constant electric field then, E, we can say E constant, is equaling alpha over 2 epsilon naught. So we know that then the net field is constant, but not equal to 0. That is the end of the solution. Thank you for watching.